thank you all for this, that you were very kind to let us get all the information from you. We had some, the trip was executed in week 10, so we had some corona impact to the trip. We had to cancel the visit to a power plant just during the trip. So we had planned to visit North Anna nuclear station, but that was cancelled in the last minute. First of all, I would like to describe the EPRI, what we found out there. EPRI was founded in the early 70s following the Great Northeast blackout in New York City, 1965. The energy industry gathered to stop blackouts instead of it should be regulated. EPRI's primary purpose is to conduct research and development relating to generation, delivery and use of electricity for the benefit of the public. And EPRI is a member organization, and the nuclear part has a worldwide members. And actually the majority of the members in the nuclear side are from outside the United States. And as I said, the headquarters is located in Charlotte, North Carolina. And EPRI has studied the use of wireless solutions in the nuclear business and gained a lot of experience. And all this research documentation are available for the members, but it could also be purchased. Regarding the wireless, the current status of wireless network in the United States power plant is like most of the office areas has Wi-Fi and also workshops, and also the majority of the turbine buildings. In the reactor and auxiliary building, there are very few installations, but some projects are planned. Few plants have necessary coverage to support moderate plant monitoring, but many of the plants are looking for solutions. And Wi-Fi is currently the dominating, but they are also looking for a DAS system, and some of the plant has DAS system installed. One concern regarding wireless equipment is the electromagnetic compatibility. And here has also EPRI performed studies in this area. EPRI has tested different equipment and their immunity against electromagnetic energy, such as pressure level and flow transmitters, various relays, seismic instrumentation, control system, nuclear instrumentation, and solid state protection system. During these tests, they have not seen any problem with the EMC for frequencies above 1 gigahertz. They have seen some equipment had vulnerable for some spectrum below 1 gigahertz. EPRI has also tested 10 wireless sensors with a mix of proprietary and standard protocols like XP, wireless HART, ISA 100, and proprietary 900 megahertz, and 2.4 gigahertz, and Wi-Fi, Zeta wave, and Zigbee. They have been testing this according to a guideline that they have produced. And the result is that the EME and RFI measurement at 1 meter are well below accepted levels. And low power sensor devices do not pose a significant risk. They have also tested and evaluated EMI and RFI from mobile devices such as common phones, laptops, and tablets. The measured radiated emissions were lower in peak magnitude than the theoretical field strengths that was calculated. Exclusion zones. There are challenges of addressing EMI and RFI, and the use of exclusion zones is one way to handle this, but it can also result in limiting wireless installations. In USA, the use of exclusion zones are widely used to avoid disturbance of sensitive equipment. And the exclusion zone distance depends on transmitter power and antenna gain and can be overly conservative and restrictive. And the exclusion zones distance can be calculated with a mathematical formula. In situ susceptibility testing, limited knowledge of plant equipment susceptibility to wireless signals is one concern. And laboratory and in-plant testing has shown most equipment is immune to wireless signals, but this should be verified anyhow. And EPRI has also developed test guidelines for EMC here. There is also a recommendation to have a frequency management plan where you define all the frequency spectra that are used, and also you can see what kind of spectrum that are available. By doing this, you can avoid some trouble with interference. If we go over to the utilities, and here I don't present the company specific, they are grouped together, but because most of the findings were common for all. And the nuclear power in the United States is facing tough competition from, among others, natural gas. For a couple of years, they had a strategic plan from the industries, which they call a nuclear promise. One of the focus is to implementing the most significant savings opportunities in the most efficient manner. And delivering the nuclear promise put new focus on plant operation. They see the transformation from traditional working methods towards new improved methods, and here we see that digitalization is necessary. And also shift the maintenance, which previously was based on time, to a condition-based maintenance instead. And this will improve efficiency and lowering production cost. To reduce production loss, they see an increase of monitoring and diagnostic for the plant components is necessary. And for fleets, a centralized monitoring center could also improve the plant production. And of course, additional monitoring requires more sensors in the field, and the biggest cost for sensors are the wiring. And here the wireless solution could be a key factor. They are cheaper to install and easier to install. And all the utilities have a quite the same portfolio of actions and tools. I mentioned some of them here. Electronic work package with an aim to reduce a lot of papers and make the work more efficient. And this will also have the possibility to get a better communication with the people in the field by using video or augmented reality to support the work. Monitoring and diagnostic. With a monitoring and diagnostic center, they can centralize system monitoring and improve predictive diagnostic and provide predictive maintenance recommendation, and also have computer to analyze plant performance. Drones, there are many different applications. For example, inspection of tanks, buildings. Also radioactivity map. and this could also be mapped to a 3D model. We have cameras. Another thing is fire cart. During the outages, you perform a lot of work in the field. You open up fire cells, and you need to have people watching the fire cells. But instead, you can use a fire cart. It's a cart equipped with a fire detection system and wireless detectors. And can also put cameras and thermal cameras on this cart. And all this information are broadcasted back to a centralized location. And in that way, you will reduce a lot of manpower in the field. Wireless sensors, gauge readers, which basically is a camera sitting on a gauge and transform it to a digital value. Vibration sensors, valve monitoring. Some of the sensors that we got some feedback from the United States. But before you can do a digitalization, the infrastructure is needed. And first of all, you need to have a backbone. And regardless of which wireless technology that you're going to use, you need this. And preferable, this is done by fiber, and oversize this. You can be sure that there will be a lot of new applications later on. And basically, there are two ways for wireless connectivity. Either you use Wi-Fi or a DAS system. Wi-Fi is widely used in the United States. There are several standards, and Wi-Fi technology are continuously evolving. And it's just to look at your private or the home market. The DAS system, distributed antenna system. This is the solution commonly used in society to enable cellular communication within big arenas or other complex buildings. In some of the Nordic power plants, this is used for cellular and radio communication, but not for applications so far. Distributed antenna system can be implemented using passive splitters and feeders or active repeater amplifiers. A DAS system that is designed with modularity could be used for several different applications by using different frequency band. For example, you can run the mobile phone, Wi-Fi, or wireless sensor in the same antenna system. One of the main takeaways from the field trip to United States was the visit at Exelon's monitoring and diagnostic center. Exelon is one of the biggest power company in the United States. They operate 22 nuclear power plants, which are located at 11 different sites. At the monitoring and diagnostic center, all the data from each plant are collected and analyzed at this center. And everything is computerized. In the morning, there is an alarm list provided for the crew to analyze during the daytime. They could also compare performance between the plants. They also identifies if a plant has a lower production than it estimated. And in that case, there will be an outgoing mail to the plant to get a feedback back what is happening. The center consists of a crew of 7 people, and they are working daytime only. There is a thermal performance specialist which tried to identify performance issues, and when found, they also notified the plant to get the answer back what's happening. And by the information that we got from Exelon was that this has been very efficient and also increased the production. For example, they have identified differences in running the power plants and also identified degradation in process systems. And the ordinary crew at the power plant handle immediate operation at the plant, and the maintenance and diagnostic center has a longer time perspective. And all actions are defined or controlled by a human, so that in that you secure the data. But as I said on previous page, one of the main takeaways from the field trip was the monitoring and diagnostic center. To summarize this approach to our power plants, I have a couple of slides here. There are different ways of centralizing the data from the plant, but the data needs to be exported to a common place like a monitoring and diagnostic center. And first of all, we need to take care of the existing data that is at the plant. We know that we already had a lot of information that need to be taken care of. We have the process control and process safety system that measures and collects a lot of data that is used for operating the power plant. But this data is also useful for others when analyzing plant performance and degradation of components. In order to keep process control and process safety system clean, the use of analysis tool should normally be outside of these systems. And the black arrow here shows the export of the data from the process control and process safety system to a common center. And to the right, we have the green arrow. We have an administrative or a TIC IT network, probably also some of the Wi-Fi equipment hooked up. And maybe in the future we will also hook up the sensors, cameras, and also mobile worker tools. And this data should also be broadcasted into this monitoring and diagnostic center. And many power plants has a distributed antenna system for traditionally communication devices. For example, cellular, mobile phones. There is also safety communication in this system, like the blue light communication for fire, ambulances. But the DAS system could also be used for connecting different kind of sensors. This means that the DAS system could be used for several different applications, such as cellular, Wi-Fi, wireless sensors. And the figure tries to illustrate a DAS system with the different applications. Of course, the coverage in the plant is dependent on the frequency that are used, and lower frequency can penetrate the buildings much better. There is an example of comparison between 700 megahertz versus 2.1 gigahertz, and the penetration is 2 times better for the 700 megahertz equipment. And this must also, of course, be accounted in the design of the system. There are solutions for tapping off data within the power plant to a private cloud. And this solution could be desirable for power plants to ensure full control of the data and also avoid additional cost for subscription by the carrier. But the data could also be distributed via the carrier and brought back to the power plant via the called public or a secured cloud solution. But you can see here there are many different solutions for an infrastructure that support digitalization. And the figure illustrates different approaches that we discussed during the trip. So a little bit of summary here. If we look for strategies regarding infrastructure, prerequisite for digitalization is the infrastructure, which is called enabler. And as I mentioned earlier, there is not one kind of solution that suits all power plants. Instead, this needs to be analyzed case by case. You will see a way forward for doing this. But first of all, the backbone. This is regardless of which wireless technology that should be used. All solutions need to have a backbone. And preferable, this is done with fiber. A fiber backbone could also be used for all kind of system that is going to be implemented in the future. So, for example, if you want to have a new distributed process system, you could use this infrastructure. To secure future expansion, oversize the backbone because the cable cost is much lower. Also consider redundancy and separation when designing a backbone, and also look for power feeding for the equipment. We also believe that there are some kind of existing infrastructure that could be reused at the power plant. So analyze what kind of old infrastructure there are able to be used. Then the next step is to identify all use cases and also try to look into the future. What kind of new future applications are there? And do a prioritizing of these use cases, and also look into the life cycle cost here. Established consolidated infrastructure. When the prioritizing is done and a consolidated infrastructure could be established, which include defining wireless system and also subnets to the system. Modular design. Aim to have a modular design which allow or make it possible to add more applications in the future. Ability to implement new technology with minimal hardware changes so that the infrastructure could be reused, like antennas and different kind of access points. And as said earlier, also develop a frequency management plan to align the best frequency for all the application. And cooperation with the normal IT. Usually power plants has a separate IT department, and it's recommended to involve the IT since they have an experience of network and wireless solutions within the company. It's better to combine this knowledge between the admin IT and also the process IT. And just go ahead. To summary, our conclusion from the trip, common for all visited companies was that the nuclear power plants has to reduce cost in order to be more competitive at the market. And the common denominator for all utilities that we visited was the digitalization. More measurement and data will enable power plants to go from a time-based maintenance to a maintenance based on condition instead. The use of electronic work package was another goal for maybe not all, but almost all of the power plants. And the prerequisite for the digitalization is the infrastructure, which is the enabler for this transformation. And that there is no one kind of solution that suits all power plants, but instead this is needed to be analyzed case by case. And the use of exclusion zones for wireless equipment are used in the United States to solve the issue with interference of sensitive equipment. And from the team, we have some of the recommendations for Energiforsk or ENSRIC. And it's look into the design of a backbone at the power plant. How could this be done in a best way? Do some studies regarding DAS solution, where you use a modular system and the private cloud solutions. Another area that we think should be looked at is the use of exclusion zones, because one of the biggest concerns is to prove that the wireless equipment don't interfere with sensitive safety equipment. Look into how a monitoring and a diagnostic center could be built up, and which kind of tools that could be used there. And also the handling of all this data, the big data, what kind of environment supporting application tools that could be used. And there could also be some work be done for a use case. If you look into a motor and pump application, what kind of monitoring should there be to get a better maintenance for that kind of equipment? Recommendation to the power plants is actually to build backbones and start analyze what kind of data that is available and how this could be centralized to one common area. And also analyze how the use of existing data could be used to improve maintenance and implement condition-based maintenance instead. We saw on some of the utilities that they had they called it Fix It Now team, and it could be if you go for a wireless solution, you need more monitoring. You will probably see that you need quick new monitoring in the field, and there could be a wireless team that just focus on how to install this kind of equipment in the plant. And also another team for analyze equipment, helping the maintenance. Regarding competence, we see that probably this new digitalization and the wireless technology need a kind of new competence here. So it would be good to analyze this. What kind of, how the competence look at the power plant regarding this. That was my summary, or the team's summary from the trip, but I would like to hand over to the teammates to get their personal view of the trip and their main takeaways from the MPP. I don't know, but I hope that Petri is available.
Yes, Fredrik, can you hear me?
Yes, I hear you very good. So please describe your takeaways from the trip, Petri.
Okay. So I participated in the trip as a Fortum representative, and first I would like to thank Fredrik and Energiforsk for arranging this trip. Fredrik spent a lot of hours preparing, and thank you. So in Fortum we are just starting on investigations on the possibilities to upgrade old equipment with or in general to upgrade them, and Wi-Fi and DAS systems could be potentially used in these applications. So this trip was, or the timing was perfect for us, as we haven't done so much in the field yet. And the visits and the discussions provided a lot of interesting information, and it was really beneficial to see actual implementations of the use of these wireless and DAS systems. And also it provided information on how to recognize the possible pitfalls in advance, so that we don't do, let's say, the same mistakes that some of the utilities in the US have done. And finally, I think that with these points in mind, that this information will provide support for the decision making on what we will do, and help us in that regard. So that's all from my side.
Well, thank you, Petri. I would like to hand over to Ringhals. Samuel or Patrick, are you available?
Samuel is here.
Good.
Can you hear me?
I hear you, yes.
Yes. Well, I also want to thank you for the opportunity to go to this trip, both Fredrik and Strick. At Ringhals, we are looking into the wireless implementation at Ringhals 3 and 4, and this journey, I would say, gave us a lot of new experiences. I think both EPRI and many of the utilities showed the use of DAS systems, the modular antenna system that supports several radio systems, and this is something we have actually built at Ringhals, but not for the use of sensor networks, and this is something I think we should investigate if they are suitable for that in the future. I also take with me the use of exclusion zones. I think it's a good way to get acceptance for wireless systems, even if it might be a little conservative. Yes, I think that is summarize what I learned from this trip.
Thank you, Samuel. Something that you, Patrick, would like to add?
Yeah, hi. Patrick Larsson, I'm also a Ringhals representative. Again, I also give thank you to Fredrik and Strick. And as Samuel mentioned, there were some Ringhals project analysis with respect to wireless ongoing. I think this is a good information to that project, and I was really impressed how the companies really showed how the digitalization could be a reality. So that was really, really good, and I think if future wireless networks together with the existing and future wireless networks will form the basis for an intelligent MPP where workers and equipment easily can be connected anywhere, anytime with anything. And if not taking the big amount of existing wired plant data in consideration at the same time, we're making the digitalization of the movies more or less a total fail in analysis and our overall perspective. And I think finally the strong business cases will aid to enable the enablers. So thank you.
Thank you, Patrick. Hand over to Tobias at Forsmark. Are you there, Tobias?
So I suggest that we wait and see if we get hold of Tobias later on.
Yeah.
And before we start with the questions, I would just like to mention that Fredrik will summarize all this in a report that will be published on the Energiforsk web, and you will receive a link to the report when it's published. And you will also receive a link to the documentation from the webinar with the slides and also the video that we are recording. And if you have questions, please write in the chat box. We have, I think, 3 questions for now. And before we start with the questions, I would just like to mention 3 activities that we're working on within our digitalization program. One of them is a recently started project on industrial Internet of Things in nuclear applications that is ongoing now. And we're also discussing 2 new activities that we haven't sort of decided what to do yet, but we'll do something within these areas. And the areas are robotics and also this centralized monitoring center that you mentioned, Fredrik. So let's start with the questions. The first one was from Imre. Please, Imre.
Okay, I hope I managed to unmute my mic. Do you hear me?
Yes, we hear you. So please
present
yourself.
Yeah, my name is Imre Pajit, and I'm professor at the, we have now a very strange name, subatomic high energy and plasma physics, but originally that was the Department of Reactor Physics in Chalmers in Niels Göran Sjöstrand's time, and then we became nuclear technique and so on. And now we are part of a bigger constellation. Okay, I put my question a little bit ahead of time. That was before Fredrik put on a slide which showed the Exelon Monitoring and Diagnostic Center, because I had actually in mind a question regarding such a diagnostic center. Namely, I wondered whether it was possible to receive measurement data from power plants to outside places like a university in order to do analysis of the signals with the purpose of diagnostics and monitoring. We have had a cooperation with Ringhals, I think about 25 years now, to do such type of work, but those are based always on offline receiving the data offline and doing the measurement afterwards. But I'm inspired by an experiment which was performed at the end of the 70s, when in the Netherlands, which only has or had one single pressurized water reactor, the Borssele reactor, they had a direct telephone line to the Patton Research Institute, and those people working with noise diagnostics could make analysis and develop methods and so on. And I have been dreaming for very many years about something similar in Sweden, getting data online. And that is exactly what Exelon does with this monitoring and diagnostic center. Several years ago, we even had an application to Vetenskapsrådet. It was called Diagnostic Centralen in Swedish. So my question is there any reality of thinking something like that in Sweden, in which the power plants would be interested? I can give you examples what type of work we do, but I don't want to take too much time. Core barrel vibrations, void content, void velocity, detector string impacting, moderator temperature coefficient, and so on and so on. And that could be monitored. So anyway, the essence of my side, if there is any such plans in Sweden, then I would be very much interested to have such a thing in Chalmers as a diagnostic center. Thank you.
I like the idea, but I think we should hand over this to the utilities that are online here. At least we have the people from Fortum, Ringhals, and Forsmark. Do you have some?
I can address that question a little bit. Thomas Med, Forsmark here. Imre, I'm very, very familiar with the work that Imre and his colleagues has done, and it's quite good work that they have done during the years. And presently we are relatively far away from what you are suggesting, because not even at the plant do we have that kind of data when we're talking about this kind of sampling frequency. And I actually doubt heavily that Exelon has that either. We have already feeds from our Plant Explorer to the authorities, for instance, but then we talk about sampling rate 1 per minute. For IMRE's type of analysis, you need at least 25 hertz, preferably 50, 100 hertz or so. And even when we analyze that kind of data on the plant, we first have to record it at the measurement computer, and then we take out that kind of file that we would also send to Imre and his colleagues. So presently we are, it's a nice idea, but we are some distance away from that at this point in time.
Okay, thank you. That was a very good point, of course. But one could probably go kind of piecewise, so that some analysis we can also do based on very low sampling rate, basically on static. I mean, yeah, 1 measurement per second is very slow, but that could help developing, I mean, the whole methodology or technology or the infrastructure to later applications when higher sampling data transmission will become available. So anyway, it would be good to keep this thing alive.
Just one last little comment. Your Freudian little mistake there sort of illustrates the problem, Imre. You said that 1 per second is very slow, and I agree with that from your perspective. But what we have presently is 1 per minute.
Yeah, 1 per minute, sorry. Yeah.
So it's 60 times slower than what you regard as too slow.
Okay, so that's a static signal, but still it would be interesting to try it.
I totally agree with you. I would love to be there, but I'm just sort of trying to sketch where we are right now.
Thank you very much, Thomas and Imre. Let's proceed then with the next question, Eva. Do we have Eva Gustafsson still in the meeting? No, let's proceed then with Carl Bergenheim.
Hello, can you hear me?
Yes, we hear you.
Perfect. Hi, this is Carl here from Camcom in Gothenburg. I have a question regarding the implementation of the wireless technology. What is the main resistance to that? I mean, is it the reliability of the device or devices that you implement and the services that they provide, the reliability of that due to deficiencies of wireless, or is it the fear that the wireless will disturb the other critical devices already there in the nuclear power plant? Why this conservatism, in other words?
I can highlight my point here, and I think it's frightened of disturbance of sensitive equipment. But I would like also to have the other teammates, they're working more closer to the plant. What's your suggestion there? Samuel, are you still available?
Yes, I'm here. I say the same thing. It is the EMI and RFI issues, I think. Our power plant managers are very afraid that you disrupt the sensitive equipment.
And I could add that also one obstacle is to prove the positive use case, that you really get benefits from the spent money.
Yeah.
Okay, thank you. And it seems that Eva has some problems with her microphone, so I will read her question. Have you evaluated the cost of a monitoring and the digitalization center, Exelon is a huge company with a lot of power plants, but for the Nordic owners, the fleet is significantly smaller. Will it be cost efficient to implement the private cloud?
No, at least not in this study. We hadn't looked into that kind of business case for this application. But I believe that this could be done. You don't have to do it big as the Exelon. But anyway, I think the data is valuable for the power plants to take care of and analyze.
Okay, do you hear me now? I changed my microphone settings.
Yes, we can hear you.
Okay, thank you. Okay, thank you, Fredrik. So my follow-up question is, since Exelon is so big and have so many power plants, the experts evaluating the data in that center, they can make, they learn by analyzing a situation from the different plants and can apply that knowledge when something happened at then some other plants at another point in time. So I think that may be one reason they have invested so heavily in this. But for like Sweden, where we have only a few power plants and must consider export control, so maybe we can't even do something together with the neighbors and the colleagues in Finland. So that was the basis for my question, that we may not be able to take advantage of everything that Exelon is taking advantage of. Do you have any comments on that?
Yeah, I think you're right there. They have a fleet advantages, but I still believe that there is value to use the existing data and also by implementing more monitoring capabilities and centralize the monitoring and the diagnostic. I believe that it will be possible to get some positive business case. You maybe don't have to make it that kind of big, but in smaller ways to do this.
Okay, sounds good. Thank you.
Thank you. And then we have Sven-Olof Palm.
Yes, Sven-Olof Palm, working at Forsmark nuclear power plant, and I work quite a lot with standardization in IEC and IEEE. And there have been some work in this area with wireless and remote control and so on, remote controlled equipment. And in this work, have you anything that you could give us as information about the support that the existence and the developing standard could support you in this project?
The feeling that we got from the utilities was many of them would like to use open protocols to not narrow the market, so they will be dependent on one supplier. To use more open protocols.
But these standards that are developed in INC, for example, they are not restricting in any way. It's about principle. The problem with cybersecurity, that's more the general background, what you need to think about. And as the question before, what's the problem with the wireless devices and so on. So I don't know if you have read the standards that I refer to.
I don't really know what to answer there, but what I see that this kind of system is that it's an additional to the. It should be different and not connected to the control of the plant. It's a separate island where you monitor and diagnose your equipment. It's not connected to the process or the safety systems. That's the understanding what we got from the United States here. And data security, as Exelon mentioned for us, is that all the data is exported and the decision is made by a human, not by the computer. The computer is helping them to get a decision, but the final decision is made by the human and the crew.
Okay, thank you. Let's proceed. Eric.
Hello, Eric Perrier from EDF R&D. I listened to your presentation. Thank you. And I have a question about the options that you detail about wireless infrastructure. It was, you said there were two solutions, either DAS or Wi-Fi, and you didn't mention anything about LTE systems and the ability to deploy LTE systems for some of these applications. Why don't they deploy this in the US?
You said LTE?
Yeah, LTE private systems, like 4G private systems. We deployed that kind of system in one of our power plants, and I wanted to know what the status in the US for this kind of systems.
Samuel, you might have to help me out here, but they are working with the DAS system together with the carrier. So they have solution, and EPRI had a test environment for setting up this kind of solutions with different kind of carriers. So, and I see that kind of technique is part of the DAS system. It's one way to use the DAS system in a better way.
Okay.
Do we perhaps have Arto Laikari, if he would like to comment on this? He did our previous mapping on wireless.
Sorry. Hello?
Hi, do we still have Arto Laikari in the meeting? No, he's not. He did the mapping that we did a few years ago on wireless in the nuclear sector. So I was just wondering if he could enlighten us on LTE. So we have one final question. Sorry, we've been running a little bit late. It's once again from Carl.
Thank you. I think this was covered by Sven-Olof, who opened this up, basically which standards would apply to these wireless systems, and I understand that 62988 would cover, unless Sven-Olof has some other insights. Is there something newer, perhaps?
From a Swedish side, we haven't worked so much with this 62988. It was published 2 years ago. So I'm not an expert on the area, and that's why I put out the question here when it's people that have actually been working with the issue about wireless. I thought I could get some feedback if we need to work a little bit more on this topic, or if the standard support is good as it is today.
Yeah, thank you.
Okay, thank you very much, everybody, and a special thanks to Fredrik and the NPP experts that went on the trip. It was really a close call with Corona breathing down your necks, but you got there and you got home too, so that was very good. And thank you everybody that participated. I will send you an email as soon as we have put up the documentation on the web. Thank you very much and have a nice week. Bye-bye.
Thank you.
Thank you, Fredrik.
Thank you.
Thank you.